In the vast expanse of the universe lies a mystery so profound it challenges our very understanding of reality. This is the story of dark matter, the unseen force that holds the cosmos together. Dark matter, a term first coined in the 1930s, refers to a type of matter that does not emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Despite being invisible, dark matter is thought to make up about 27% of the universe's mass and energy content. To understand dark matter, let's consider the Milky Way galaxy. Imagine you're looking at the night sky and you can see countless stars that make up our galaxy. However, these stars, along with all the other visible matter such as planets, gas, and dust, account for only a small fraction of the galaxy's total mass. If we only account for the visible matter, the gravitational pull would not be strong enough to hold the galaxy together. The stars at the edges of the galaxy would be moving much slower, and many would be flung out into space. But observations show that stars at the edges are moving just as fast as those near the center. This discrepancy suggests that there is additional unseen mass providing the necessary gravitational force to keep the galaxy intact. This unseen mass is what we call dark matter. Think of dark matter as a kind of cosmic glue. It doesn't interact with light, so we can't see it directly, but its gravitational effects are unmistakable. Without dark matter, the galaxies would not be able to maintain their structure, and the universe as we know it would be vastly different. The first clues to dark matter's existence came from the motions of galaxies. In the 1930s, Swiss astronomer Fritz Zwicky observed that galaxies in clusters were moving faster than expected, based on the visible matter alone. This suggested the presence of unseen mass. Further evidence came from the study of galaxy rotation curves. Stars at the edges of galaxies were moving at the same speed as those near the center, defying Newtonian physics unless an unseen mass was present. Gravitational lensing, where light from distant objects is bent by massive invisible objects, also points to the existence of dark matter. So, what is dark matter made of? Let's break it down with a simple example. Imagine you're at a party with a bunch of balloons. Some of these balloons are filled with air, making them light and floaty. Others are filled with water, making them heavier and less bouncy. Now, imagine there's a balloon that you can't see or touch, but you can feel its weight when you lift it. This invisible balloon represents dark matter. We can't see it, but we know it's there because of its gravitational pull. Scientists have proposed several theories about what dark matter could be made of. One leading idea is that dark matter could be composed of particles called WIMPs, weakly interacting massive particles. These are like our invisible balloons that have mass and create gravity, but are otherwise undetectable. Think of WIMPs as ghost particles. They're hard to spot because they don't interact with light or regular matter in the usual ways. They pass through us and the Earth without us noticing. But in a galaxy, there are so many of them that their collective gravity holds everything together. There are other candidates for dark matter too. Axions, for example, are tiny, lightweight particles that might solve some puzzles in physics. Then there are sterile neutrinos, which are a bit like regular neutrinos, but don't interact through the weak nuclear force, making them even harder to detect. Imagine you're in a dark room filled with invisible balls. If you swing your arms around, you might not hit any because they're so small and slippery. But if you could measure their weight, you'd realize there's a lot of mass in the room. That's what we're trying to do with dark matter. Find ways to detect these invisible balls by feeling their weight. Detecting dark matter is one of the biggest challenges in modern science. Imagine trying to catch an invisible fish in a dark ocean. You can't see it or touch it, but you know it's there because of the ripples it makes in the water. Scientists use special tools and experiments to try and detect these ripples made by dark matter. One way they do this is by building huge detectors deep underground. These places are chosen because they're shielded from other types of radiation that could interfere with the experiments. These detectors are like giant nets made to catch the tiniest signals. They're filled with super-sensitive materials that can pick up the faint interactions of dark matter particles with ordinary matter. Another way scientists search for dark matter is by using powerful machines like the Large Hadron Collider. This machine smashes particles together at incredibly high speeds, hoping to create and detect dark matter particles in the process. When particles collide, they can produce a shower of different particles. Scientists sift through this shower, looking for anything unusual that could indicate the presence of dark matter. Think of it like smashing two watermelons together and trying to find one specific seed in the explosion. It's a tough job, but by studying these collisions, we hope to find clues about dark matter. Scientists are also looking to the stars. Space telescopes, like James Webb, will provide new ways to observe the universe and search for the effects of dark matter on a cosmic scale. These telescopes can see the light bending around invisible masses, which could be dark matter. By studying how light from distant stars and galaxies bends, we can map out where dark matter is and learn more about it. Understanding dark matter is crucial because it plays a key role in the formation and evolution of galaxies and the large-scale structure of the universe. Without dark matter, galaxies as we know them would not have formed. Dark matter acts as a cosmic scaffold, providing the necessary gravitational pull to gather ordinary matter into galaxies and clusters. Its influence is seen in the cosmic microwave background and the distribution of galaxies across the universe. James Webb and the Euclid Space Telescope will provide unprecedented insights into dark matter's role in the universe. Advances in technology may finally allow us to detect dark matter directly and understand its nature. Thanks for staying with us.